So in this example number 2, we're asked to figure out of the students that are in grade 12 taking various science courses, how many are not taking any of these three, and secondly illustrate the enrollments with a Venn diagram. So it's actually easier in this case, in order to answer part A, to create the Venn diagram first. It's much easier to answer the questions when you can see the visual representation. So the best thing to do here is, since we have the fact that there are 3 science courses, each of these will represent a set of students, and we can create the Venn diagram now in this case with 3 circles as opposed to the 2 that we had in example 1. So we will want these to overlap each other. So make them relatively large enough so that we've got sections of each. So this up here we'll call B for biology, C for chemistry, and P for physics. Now these are all the students at the VLC, so we'll call this one set V. So we know that 52, 71, and 40 are in each of the classes. However, we've also got some other numbers we need to take into account. And what we want to see is, do these other numbers, are they numbers that are going to go right on our diagram to represent the intersections, or are these numbers that are including parts of B and C? So the best way to model this situation is to work from the inside out. So of the numbers that are underlined, we can actually start with the number of students that are taking all 3 science courses, because this number explicitly tells us how many students are in that middle section of our Venn diagram, meaning the overlapping component of all 3 sets. If there are 2 students taking all 3 science courses, then we know that there are 2 students right in the middle here that are part of the biology group, the chemistry group, as well as the physics group. At this point now, if we work outward, now we can do a little bit of math to represent the other values. So if we know that there are 11 students who are taking biology and physics, that includes the 2 students that so happen to also be taking chemistry. There's nothing said here about chemistry, so we have to assume that if there are 11 taking biology and physics, that those 2 students are included in that group. Which means what we need to do then is to figure out how many are taking just this biology and physics section right here. We would need to take that total and subtract the 2 that we already have. So if we think of highlighting everything in yellow, that would represent the 11 students that are taking both biology and physics, if we ignore chemistry for a moment. However, we know that there are already 2 students in the center of our Venn diagram. So to fill in this component here, in order for us to have 11 in the intersection of biology and physics, we would need to have 9 in this spot here. So that means there are a total of 11 now. We can do the same thing then with the other values. So since there are 8 who are taking chemistry and physics, we can look over to the intersection of chemistry and physics, and in that intersection there need to be a total of 8 students. Since there are already 2, we know that that missing component here must be 6. Likewise, the number of students that are taking chemistry and biology, if we work backward, is 15. Since there are already 2 there, then we know that there are 13 students that are taking biology and chemistry, but not physics. Now this same reasoning can be applied to fill in the last 3 sections. So if you want to circle one of the sets, so for instance the set representing biology now, we've already got a total of 24 students accounted for, which means that if there are 52 students signed up for biology and I already have 22 accounted for, that means there must be another 30 students that are only taking biology and nothing else. And I can do the same then for the others. So for chemistry class, this was the largest of the bunch. There were 71 students. So we already have 21 there, which means there must be another 50 students to make up a total of 71. And lastly, physics should have a total of 40 students inside, and at the moment there are 17. So we're missing another 23 students to make this a total of 40. So by completing the Venn diagram, we're actually almost done. There's one more thing which we didn't have in the last example that we do have here. The one more thing we haven't included is really this first number, which said that there were 140 students taking these grade 12 science courses. So in order to answer part A, how many students are not taking any of the science courses, we've got this number 140. We have a certain number of students that are taking these 3 courses here, and we'll assume that these are the only 3 science courses in grade 12. That means to figure out the number that are left over, this white space inside of the rectangle and outside of the circles can actually contain some students as well. And remember, this stands for the VLC's grade 12 students. So some students may not need any science courses, in which case they would fit into this section out here. So if we add up the total number of students that we see inside of the circles, there are a total of 30 plus 9 is 39, plus another 15 in biology, so that's a total of 52 for biology. And now we notice that we might have made a mistake here. I might have made a mistake. Biology should have 52 students total. So I have 11 there. Chemistry and biology, there should be 15, so that works out. So I think this 30 is actually a mistake. That 30 shouldn't be there. This should be, there are 24 in biology right now, and there are a total of 52, which means there should be 28. And that will give us the correct number of biology students. So just double check here. 28 plus 9 is 37, plus 2 is 39, plus 13 is 52. Okay, so now there are 52 biology students. Just to check to make sure, there are 50, 63, 65, 71 chemistry students, which is right, and then 38, 40 physics students. Okay, so those 3 work. Now we can add up the totals. So there are 52 biology students in the red circle, plus another 56 right here, so that's 108, and the 23 would be the last number to add up. So that gives us 131. So in all 3 courses, in other words, the number of students in biology or physics or chemistry is equal to 131, which I think is what we said. And that would mean then that out of the 140 students, only 9 of them are not taking any grade 12 science. So out here, we have 9 remaining students that aren't included in any of those 3 courses. So if you're ever given a situation where you have to construct the Venn diagram, just like we did in example 1, always work from the inside out. Whether you're explicitly told how many students are in that intersection, in this case in example 2, we were told that there were 2 students taking all 3 science courses, and so on. In this instance, fill in the center or the intersection first and then work your way out, whether you're given those numbers explicitly or whether you have to calculate them yourself. So the last thing then is to talk about how to interpret some of the notations. And you kind of saw in that previous slide, to answer the last question, or part A really, we figured out there were 9 students not taking any science courses. We had to consider how many students were not in set C, B, or P. And this was the notation that I used. And so you can see here that's the same thing that's being asked in this situation. So this means how many students are not, or how many students, pardon me, are actually in set A, or set B, or set C. So in a case like this, all you need to do is add up all of the numbers, all of the visible numbers that you see inside of the Venn diagram to determine this. Now in this case, there is no outer component All right, and even if there was, that wouldn't affect our answer, because this simply means add up all the values inside of these three sets or inside of these three circles. So if we do that, we can add these up as we go along. 9 plus 1 is 10, 20, 53, 73, 88, 129. So there are 129 elements in this case in A, B, or C. Now this component for part B is asking us how many elements are in set A and set B and set C. And we know that that is just the intersection of all three. That would mean that there are 10 elements that exist in all three sets. And lastly, the number of elements in A or C, so either A or C. You can think of this by, if you have the luxury of being able to circle your sets, you can think of this as the intersection of those two. So here is A, and here is C. So you can ignore B completely at the moment because this only concerns set A and C. And now we can see that in the middle there are a total of 11 elements in the intersection. And pardon me, then this means that in the union we actually need to include all of these items within the two circles. So in A or C, then we need to add up all of the ones that we see here. So 9, 10, 20, 53, 68, and 109. And then that gives us the total amount in set A or set C.